In this lecture, we'll discuss about the classification of data structures. Friends, data structures can be classified in two groups. DS, here stands for data structures. First group is inbuilt data structure, or these are also called built-in data structures or primitive data structure. Another category is user-defined data structure or non-primitive data structure. Okay. User-defined data structures are of two types, linear and non-linear. The examples of linear data structures are array, linked list, stack, queue, and non-linear data structures are tree and graph. In previous lecture, we have got an idea about these data structures. What is tree, what is linked list, what is tree, what is graph, etc. Okay. Now, what are these inbuilt data structures? If you have written a program in C or C++, you might have seen some keywords like integer, int, char, float, double and other keywords. Okay. So these are called inbuilt or built-in or primitive data structures, or sometimes these are known as the data types because it stores a single value and the compiler already, the definition of these data structures are already known to the compiler. Okay. So these are the keywords. And the definition of these keywords are already known to the compiler. That is why these data structures are called inbuilt or built-in or primitive data types. Primitive data types means these data structures cannot be further divided into parts. Okay. Another category is user-defined data structures. It is clear that user-defined means user has to define these data structures. Compiler don't know anything about these data structures. User has to define these data structures. Means user has to define that. User has to give the definition of these data structures. User need to write functions to perform operations on these data structures. For these data structures, int, char and float, you don't need to write functions for performing operations like to read and write an integer type of variable. You don't need to write a user-defined function. It is clear to compiler. User can just declare these data structures like int a I have declared somewhere in C or C++, and I can insert any value into it without you writing any user-defined function, and I can update this variable, and see, it is similar to deleting the existing value and storing a new value. So I don't need to write functions for it. Okay, compiler knows that. But for user-defined or non-primitive data structures, user has to first define these data structures and user has to write the functions to perform operations like insert, delete, traverse, search, merge, etc. These are the operations we have seen in our previous lecture. That was the introduction of data structure. Okay. there is a data structure called array. But array I have written here in this category of user defined, but it is not completely user defined. See, there is some information that is already known to the compiler, and you can perform read and write operation into the array without writing user defined function. But I have listed out this data structure here because it is a linear data structure and comes under the category of non-primitive. Okay, this is not fully user defined. Something, if we want to traverse the array, we want to sort the array, we want to merge the array, then we need to write functions, user defined functions. But for read and write operation, we don't need to write the functions. Okay. So user can just declare the array and perform read and write operation. For rest of the operation, user needs to write user defined functions. So we can say that this is not fully user defined. Some things are user defined and some things are already clear to the compiler, are already known to the compiler. Okay. Then come to the next data structure. See, these are user-defined data structures. So, user-defined data structures will always be created with help of inbuilt data structures. Okay. For example, for array, you need to use integer, char or float. Array is a collection of homogeneous data elements, you know very well. Okay. So, array is a collection of integer type of element. If we have considered 5 elements into the array, that are 1, 2, 3, 4 and 5, then this is the array of 5 integers. User defined data structure means these data structures are created with help of inbuilt data structures or old user defined data structure. Okay, these are the 5 integer elements of array. Okay, similarly for linked list, we need to use these inbuilt or built-in data structures. For stack and queue, stack can be implemented with help of array or linked list. We will see in the coming lectures that how the stack is implemented with help of array, how the stack is implemented with help of linked list, similarly queue, tree and graph. These are the data structures which will be implemented with help of this array or linked list. Okay. So that is why these data structures are called user defined data structure. These data structures will be created with help of inbuilt or old user defined data structures, and user has to define the operations on these data structures. Non-primitive data structures, these data structures can be divided further into parts. For example, array is collection of 5 integers, int type of elements. Okay. So next is, I would like to explain linear and non-linear data structures. For this, you might be having a little bit idea of random access memory. I'm explaining here, okay? Random access memory. A city is collection of houses. A random access memory is collection of words. And in a city, see in Bhopal, if you want to reach a house, you need to first search the address of that particular house. Each and every house of the city have a unique address. In the same way, memory is collection of words like this. I have written this one word, second word and similarly there can be n number of words, nth word. Okay, and each and every word have some unique address. These addresses are generally written in hexadecimal numbers, but for the sake of simplicity I am using decimal number representation. For example, first word contain address 121. The address of second word is 122, 123, 124, 125. Okay. So, and one more example. You have seen a page in notebook. So, a page of your notebook consists of lines, different lines. Similarly, the memory consists of different words. This is one line that is analogous to one word of the memory, and minimum addressable unit of the random access memory is one word. You can read or write or perform any operation single word at a time. Okay, this word may consist of 8-bit, 16-bit or 32-bit depending upon your configuration. Okay. So, let us define these linear and non-linear data structures. Linear data structure means the elements of the data structures form a linear relationship in the memory. Linear data structure means elements of these data structures form a sequence in the memory, and this sequence can be maintained in two ways. Number one, with help of sequential or contiguous memory allocation, and number two, with help of pointers. So, linear data structures means sequence in memory. The elements form a sequence in memory. This sequence can be maintained with help of contiguous memory allocation or with help of pointers. For example, let us consider these 5 elements of the array and its storage. If memory consists of, I am assuming here memory consists of 16 bits. So this is int type of item. 1 we store on the first word. One word consists of 16 bits and we would like to store 1 into the memory. So we stored in first word. In next memory address, we would have to store 2, then 3, then 4, then 5. These are known as contiguous memory allocation. Means first item is stored on first address, second item is stored on second address, third is on third address, like that. This allocation is contiguous, means no break is there in the memory. Okay. So, the sequence of items is in the arrays maintained using contiguous memory allocation. For linked list, how this sequence is maintained? For example, we would like to store 1 in the linked list. This list we have already seen in introduction of data structures. Okay. So 1 is stored and along with 1 the address of second element is stored. Suppose your 2 is stored on the address 124. So we will store 124 here. And this is a single node of your linked list. Okay. That is, it will point to the next element, and 2 will store the address of 3. Suppose stored on 126th location. So I will store 126 along with 2. So this node will point to the third element. Similarly, 3 will store the address of next element. Say it is 129. So it will point to the next element like this. Okay. This is a single node. This is another node. Okay. So sequence is maintained. There are some empty locations. This is not contiguous memory allocation, but the sequence is maintained with help of pointers. The first element, then second element, then third element, then fourth element. This sequence is maintained in form of pointers. So that is why this is also called linear data structure, because the element forms a sequence which is maintained with help of pointers. Okay. Stack. Stack can either be implemented with help of array or linked list. So array and linked list both are linear data structure. So stack is also a linear data structure. Similarly, queue can be implemented with help of array or linked list. So queue is also a linear data structures. But for trees and graph, we never maintain a linear sequence in the memory. When I will define tree and graph, then we will see the storage of tree and graph in the memory. Okay. For this time, you can assume that we never maintain a sequence in between the items of the tree or graph, because there is no relationship between root, left children and right child. We have seen this root, left children and right children in previous lecture. Okay. So there is no linear relationship between root, left child and right child in the tree in memory. That is why this is called non-linear data structure. And graph, if we form cycles, then this data structure is known as graph. Tree is known as graph. Tree is having cycles. Tree which is having cycles is known as graph. So tree and graph never maintains a sequence among the data items in the memory. That's why these are categorized under the non-linear category. Okay. So this is all about the classification of data structures. Thank you.